Yo, what is up? Back to another chemistry review video. This is the part 2. Go check out the part 1 before watching this. But let's just dive right back into it. Okay, so now we're going to go into the classification of matter. So in the last review video and the other previous videos on this channel, we spoke about what matter is. We spoke that it takes up space and it has mass. We've talked about all the change it undergoes, the intensive properties, the extensive, the chemical, and the physical. But now we're going to classify it into big groups as elements, compounds, homogeneous and heterogeneous mixtures. So first, I'm kind of going to draw a branch system here of giving the general overview of how we can break up and classify matter. So matter can be classified as either a pure substance, or it can be classified as a mixture. So when we say that it is a pure substance, cannot be separated by either physical means, so no physical means it can be separated by. As well, it contains a uniform composition throughout. Pure substances can be further broken down into elements and compounds, which helps kind of define why it can't be broken down by physical means and it has this uniform composition. So elements, as many of you know, examples of this would be like hydrogen, helium, sulfur, would all be examples of elements. So when we say an element, it includes just a single atom. So elements all have the same atom throughout. And they cannot be separated by physical means. Pure substances can also be separated into compounds. So these include two plus elements that are combined with one another, and they cannot be separated by physical means either. So examples of compounds, the most common ones would be, let me just draw another arrow over here, like water, carbon dioxide, salt, just some basic ones like that. Okay, so we discussed how the two specific types that make up a pure substance and what a pure substance is. Now it's time to discuss what the idea of a mixture is. So a pure substance is the combination of two pure substances. That each retain. So they retain their properties and identities. Okay? But just like pure substances, these can be broken down further into both homogeneous mixtures and heterogeneous mixtures. So first of all, what is a homogeneous mixture? So a homogeneous mixture retains a common composition throughout. It's got really a uniformity to it. It's not like a compound where it's two elements joined together. It's still two pure substances, but there's a sense of uniformity and order. And there's about an equal distribution of both. So examples of a homogeneous mixture, would include like salt and water. It's a really good example of a homogeneous mixture. Another example would be tea. It's a really common example that most people are familiar with. Air. There's a general equal distribution there, and there's air. Each have different qualities to it. There's a sense of uniformity, sense of order to it. Just like there's with salt water and tea, there's not precipitates sitting on the bottom of it. There's a sense of uniformity throughout, and there is with tea as well. There's not different clumps and different textures. So it still is two pure substances that are combined with one another, just like salt and water, NaCl, and still H2O, but uniformity and composition throughout it. The next example would be a heterogeneous mixture. So when we're referring to a heterogeneous mixture here, think that it's still two pure substances combined together, but there's no uniformity, no, it's not as cohesive as, say, a heterogeneous mixture. It's got disorder to it, as the composition varies from point to point. And some examples of a heterogeneous mixture would be, sand, a salad, and anything along those lines where there's not a sense of uniformity, cohesion to it. Also, I should mention that a homogeneous mixture is also called a solution. That's important. Star that. The last idea that I'm going to discuss and talk about is an intro to really the periodic table, which will be the backbone of this course. So if we're looking at it here, the first thing that we're going to look at is locating where everything is. So if we're looking at here, up and down all through here, is really, even here too, these are all of our metals. This is our group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 groups of metals. And our nonmetals are all over here. And on the last row here is where our noble gases are. So just review, everything up to this point is our metals. The ones that are on this staircase here are our metalloids. And this last row here is our noble gases. Up here is the lanthanides and the anthanoids here. So kind of going over the characteristics that each really maintains. We can see our metals maintain a strong conductivity. You can think of it as copper, and think about your phone. There's tons of metals and very precious metals that allow your phone to work. So just think metals, strong conductivity, metals, strong conductivity, metals, strong conductivity. And nonmetals are the opposite. They're non-conductors, if you want to think of it in that sense. And metalloids, they're kind of the in-betweeners. They're like, I'm not the best. They're really indecisive. I guess you could say indecisive. Also, the nonmetals tend to be very brittle solids. Also, I should mention that going down the rows here, these are all the groups. So everything on this going downwards, groups. Going across is the periods. So this would be period 1, period 2, period 3, period 4, period 5, period 6, period 7. Think about how you read your schedule, right? When you say you have period 1, period 2, period 3. You're not reading your periods this way. If you're thinking about your courses, you're reading them down. So periods across, groups down. Groups across, periods side to side. Okay? I think that kind of wraps up everything in this chapter. I'm really hoping this prepared you well for the test. Just kind of think about each question. The best advice I can recommend for studying for the test, go over the PowerPoints / go over the notes, and think about examples. Examples are very key in your study throughout chemistry for the entire year. And if you have any questions, watch this video, or more specifically, go talk to your teacher. This is Christopher Zeuthen, signing out. Have a great day.